Hi, welcome back for the second week. So this is the heating and air conditioning lab, week number 2. The first week we're actually going to talk about anything useful except for the syllabus. It'll be kind of short. It's hard to do as much in video as you can in person. We won't be taking anything apart, but I'm going to start by just looking over the components of the cooling system on one vehicle. Now, not all cooling systems are identical, so this isn't going to be a complete explanation of how every cooling system works. That and the camera can be pretty difficult sometimes to get a good view of exactly what I'm looking at or what I'm talking about. So I just want to identify the components and make note that this particular cooling system doesn't have a coolant recovery bottle. It has a surge tank, a pressurized plastic tank that the expansion and contraction happens inside that, and you don't actually have coolant flowing from the pressurized system into an unpressurized system and then back again. So this entire system is pressurized. After that, I'm going to hook a scan tool up. We'll run the vehicle and watch the engine coolant temperature sensor as the vehicle warms up. And I kind of want to show you that at first the thermostat will be closed. The thermostat will be closed, and what that does is it blocks the coolant from reaching the radiator and getting cooled down, essentially. So that helps get the engine temperature up more quickly. And then once the engine temperature reaches where we want it to be, usually around 195 or so, the thermostat will open and allow coolant to flow through the radiator so that it doesn't continue to get hotter and hotter. We'll also see how the cooling fan on this particular vehicle works. They don't all work the same, but this one is probably pretty typical nowadays. After that, I have a couple of thermostats, and we'll bench test those and see how they actually work. So let's get to all that, and then I'll come back and just kind of wrap things up. So the first thing we just want to do is look through the components of the cooling system. We're not going to talk anything about air conditioning yet, just the cooling system on this GMC truck. There are a lot of different setups that you might run into. We'll just look at this one and talk about it a little bit, identify the parts, and then we'll hook up a scan tool and see how it actually works. So I guess we'll start with the major piece. It's kind of hard to see. The major piece of the cooling system is the radiator, so it's on the other side of the fans here. Here are the cooling fans. There are 2 of them on this vehicle. Here we have the upper radiator hose. Upper radiator hose goes over here to the water outlet. That's where the thermostat's going to be located. That's going to control the flow. Lower hose, a little harder to see down here. That's feeding into the water pump. So the flow on this system is going to be out through the upper hose, through the radiator, and then out of the radiator, out of the lower hose, and into the water pump, which will then force it into the engine itself. Over here on this side, you can see we have a surge tank. Surge tank is actually a pressurized part of the cooling system. It's not like the overflow tanks on some of the older systems. This cap on it says 15 psi, so you need to make sure that the cooling system is cool before opening that cap. Here is a view of the heater hoses. So the heater hoses run out of the engine, and kind of hard to tell, kind of hard to see, but here they are down here. They provide hot coolant to the heater core to give us our heat. Here's the other cooling fan on this side. The grill is actually part of the cooling system. If it's not clear, we're going to have a problem. Inside, see if we can get a good shot, you've got the fins, tube and fins of the air conditioning condenser. Behind that is where you'll find the radiator. I've hooked up the Autel scan tool. Let's let it acquire the vehicle here, have it read the VIN. Okay, that is correct. And that's correct. So 5.3, L83. And it's got to go through and pick up all the different modules. The only one I'm interested in is engine control. There is an HVAC control module here, but for right now, I just want to see engine control, because what I'm interested in is engine coolant temperature. I just want to show you how the cooling system regulates engine coolant temperature to usually somewhere around 200 degrees, 195 maybe. So we'll pick the engine control module, and we got the 6-speed. I just want live data. I'll pick, as soon as it gets around to it, engine cooling and HVAC. And very first thing we have here is engine coolant temperature sensor. So right now, 127.4 degrees Fahrenheit. Normally on a day like today, it would be much colder than that, because it's about 19 degrees out today, but I just drove this here and brought it into the shop, so we're not starting from ice cold. What I'm going to do is start it. We can look at cooling fan command. Right now the cooling fan is commanded off. We can look at coolant temperature, and I want to show you that it will reach a certain point, and then it should regulate pretty much there. So let me start the engine and I'll talk about it while that's going on. Probably going to take a few minutes for this temperature to start rising, and I don't want a video of just staring at this screen all day, but I want to make sure it's actually reading live and moving. You can see I do have the HVAC system on. When you put it on auto, it pretty much runs that compressor all the time. That's to dehumidify. It definitely helps with the defroster. Okay, so we're seeing the engine coolant temperature beginning to rise, and we'll see just how far that gets. And if we wait long enough, we'll eventually get the cooling fan to come on high speed. The reason it's probably running at all right now is because we do have the AC. I'm going to shut the HVAC system completely off. We should see the compressor clutch relay go off and the AC request signal go off. So compressor's off now, AC request off, cooling fan command you see came down. When we talk about air conditioning, you'll see that the fans are necessary for the air conditioning system to work, but we don't really need them for the cooling system until we reach a certain temperature. So what we're looking at now as we watch this temperature increase, the thermostat right now would be closed. With the thermostat closed, coolant is circulating around the engine, but it's not going out to the radiator. What's the radiator's job? Well, just what it sounds like, it radiates. So heat is absorbed into the coolant from the engine as the coolant travels through the engine. And then when the temperature reaches whatever that set temperature, usually about 195, the thermostat will open, allow coolant to flow through the radiator and start dumping that heat off to the outside air. When you're driving down the road, the cooling fan might not be necessary at all, but at some point, especially in traffic or if you're stopped, even with the thermostat open and coolant flowing through the radiator, unless you have good airflow over the radiator fins, you're not going to have sufficient cooling. So the thermostat will open at one temperature, cooling fan will kick on at another temperature. I jumped ahead a little bit here. It didn't just magically go from 150 something to 172, but we're starting to get a little bit closer. Notice the intake air temperature sensors. You know, they're not really, they're going to be affected more by the temperature in the shop here as air is drawn into the engine. But this is the one that we're concentrating on now, engine coolant temperature. And it's not climbing real fast. The engine's just at idle. Maybe I'll go, you know, rev it up a little bit, see if we can get that temperature up more. I do want to tell you the upper radiator hose right now is pretty cool to the touch. It's not stone cold because I have been driving this thing, but I can tell that it does not have hot coolant running through it. After that thermostat opens, it may be difficult to impossible to actually hold on to that upper radiator hose without burning your hands, because it will be almost 200 degrees at that point, the coolant. Let me go give this a little gas. That did help a little bit. Skipped ahead again a little bit more now. Here at 185, I'm starting to feel that upper radiator hose get pretty warm. Not too easy to hold on to. I don't know what this thermostat is set for, but I do want to tell you there are two different kinds basically in the way they operate. Some of them, as the temperature goes up, they begin to slowly open and let a little bit of coolant through. Others are very sudden. They go from pretty much completely shut to popping open, pop-it style thermostat. This one I'm going to say is probably slowly opening. I'm going to try to look up and see exactly what the temperature setting for this one is. Right now you can't see what I'm doing, but I'm bringing up all data so I can actually check what the setting of that thermostat is supposed to be. Alright, I'm selecting GMC truck 2015 Sierra 1500 with the 5.3. So I just looked it up, and the thermostat should begin to open at 188. I'd say that seemed to be about correct. Coolant temperature was 188. I could feel the upper radiator hose getting hot. Supposed to be fully open at 206, so there will be some increase in temperature. If this were a hot summer day and we were outside, I'm thinking that this would be going a lot faster. So I just keep jumping ahead so we don't have to sit here and watch all day while the temperature rises. Alright, we're up to 204.8. That's getting pretty close to the fully open temperature. I noticed the cooling fan command came up a little bit. Usually in my experience, cooling fans have kicked on about 212, give or take. So we're getting close. I'm going to go hit the gas a little bit more, try to drive that temperature up some more. Alright, 212, I think I see the cooling fan started turning a little bit. 15, 14. Now we've hit 213. I'm going to go see if I can hear the fan running. Very slight airflow through it. Our temperature is really not rising anymore. I'm going to go hit the gas some more. Try to drive that temperature up even more and see if that fan comes on a little bit more. That actually had a little bit of the opposite effect. Having all that coolant flow brought the temperature down a bit. Well, let's let it sit. What you normally see on a hot day is that temperature will peak somewhere around 212, 214. The fan will kick on and then you'll see that temperature drop back down. If the temperature is regulating, in other words, it doesn't just continue climbing, if it hangs out now, it looks like it's doing that. It's going a little above 212. The fan is running just enough to keep that temperature from rising. Older vehicles, the fan would come on full speed, the temperature would drop quite a bit, maybe 5 or 10 degrees, then the fan would kick off and the temperature would go back up. I just want to see where this bottoms out. But as long as it's fluctuating within a range just above 200, 210, 215, I'm going to say that everything is working correctly, and I have not had any trouble with this system. Yeah, dropped down to 206. Now it's creeping up a little bit. So, see the fan speed just, when it creeped up a little bit, the fan speed kicked up a little bit. It's running it just enough to keep that temperature where it wants it. So the purpose of the cooling system, and I just want to make sure you understand this too, it's not to keep the engine as cool as possible. It's to keep the engine at a predictable temperature. So everything is machined in the engine, everything is designed to run at a specific temperature most efficiently. And so the cooling system is designed to keep the engine at that temperature regardless of whether it's a hot day, a cold day. So by knowing that the engine's going to run in that pretty tight range, it looks like from say 205 to 215, then everything can be designed to be optimized for that temperature. So next what we'll do is we'll actually look at how a thermostat works and bench test one. In the shop you saw how thermostats work in the vehicle. So the objective here is to show you what a thermostat looks like. You know, here's two different ones. Neither one of these is actually the thermostat out of that vehicle. Just two different shapes. Typically, the side with the spring here is facing away from the radiator in towards the engine, and this side is facing towards the radiator. And I'll find a little video. I know there's a how it's made video on how these work, but essentially there's a wax pellet in the middle of it that when it gets hot it expands and it forces this open against the spring. As it cools, the spring pushes it closed. So I have the two thermostats. I have a little pan of water here and a hot plate. And right now the water, you can't see the thermometer, I know. 62 degrees Fahrenheit, so pretty cold right out of the faucet. I'm going to start with this thermostat here. Just drop it in the water. And not sure how easy it's going to be to see. Let me see if I can get this up in front of you at all. But where it seals is right in here. And when this is open, you're going to actually be able to see a gap right here where I'm pointing. Hopefully. You know, the focus is a little off, I guess. So let me set that in there. That's about as full as I can get this. I'm going to turn this hot plate on high. And I'm not sure how long it's going to take for this to actually reach boiling. So we may have to come back after a few minutes. Let's see. Well, the thermometer is steadily climbing. A couple tenths at a time. 64, 65, 66. Okay. I think I'm just going to let it ride because I don't think at this rate it'll take that long for it to open up. Yep. Actually, maybe we'll let that ride and I'll be back. So you may be able to see we're now at about 162. I think actually you can see that thermometer if I get the angle just right. And you know, the spot we want to watch, of course, is right here. This centerpiece will push downward as the thermostat opens, and we'll see a gap developing between the two pieces. So let's see where we're at. Starting to make sounds like it wants to boil. We're up to 170. Getting a little hard to hold on to this thermometer. 172. Obviously 212 is what water boils at, so we won't be able to get any hotter than that. But they typically open around 195 or so. So here we are at 177. Water's starting to think about boiling. At some point soon, if this thermostat's any good, we're at 180, 181, we will start to see it moving and opening up here. 182. I'm beginning to actually be able to see just the tiniest little bit of light in here. It's going to be very difficult, I know, on the video to see it. I've got 185. And if I can, I'll grab a hold of that and hold it up better so you can see. We're definitely getting a gap though. 189, 190. Yeah, it's beginning to open farther. Don't know if there's any angle I can get it at that'll show you that. But once it opens up real far, I'll hold it up in front of the camera and hopefully you can see the gap. 190. We're at 195 now, and it is definitely definitely at least partially open. 196. Oh yeah. Well, let's give it a try here. Let me grab a hold of this and see if you can see that there's actually no, I don't think you can, but I can actually get the tip of the thermometer between the two pieces here. Throw it back in. See what our temperature is. So we're over 200 now. And yeah, I can push the thermometer right on through. Let me get a hold of this. I can push it right on through here, sticking out the other side. Let me turn this down and see if I can get it focused in a little bit better. Yeah. No, it's starting to close up. Drop it back in a minute. Let me crank the heat back on here. I want to get this open wide enough that you can actually see it on camera. I actually think you can. Right back in here. Thermometer goes right through it. Oh yeah, you can see that it's open. 205. Let's shut this off. Yeah. There's an opening right here that I can put the thermometer right through. Now we'll let that sit. You can see the opening in it. You can see light here. See my hand behind that. And as it cools, that'll close right back up. Yep. Still a little bit, but I can't get the thermometer through there anymore. Meantime, I'm going to throw this other thermostat in. Check our temperature. It might be a little easier to see. So let me do that. Yeah, I can see through it, but I doubt you can. Little gap right there. Okay, this one was definitely better. It's completely closed now. I can see, no light through it at all. So probably as soon as it got below about 190, it closed back up. This one here, it is opening, but It's just so much smaller that it's kind of hard to see. Get a hold of it. But there is a gap in it right here. Much better, obviously, if you're able to do this in person. You're able to see it a lot better. The camera just doesn't capture it as well. So I'll put on that video, that how it's made video. You can see how thermostats are constructed and see the wax pellet that's inside that expands and causes it to open.
Only about 5 centimeters in diameter, a car's thermostat sits between the engine and the radiator. Until the engine warms up, it blocks the flow of coolant to the radiator. When the engine reaches about 95 degrees Celsius, the thermostat opens, letting coolant flow through the radiator and into the engine to prevent overheating. The key component inside the thermostat is wax. When the engine heats up, the wax melts and the thermostat opens, triggering the cooling system. The wax melts quickly because it contains powdered copper, graphite, and/or aluminum. As the wax transforms from solid to liquid, it expands. The pressure pushes a pin that opens the valve that enables the flow of coolant to the engine. After heating and mixing in the powders, workers pour the wax into slab-shaped molds. It takes about a half hour to cool and solidify. Then they extract the slabs and grind them up. They feed the granulated wax to a pill-making machine, the kind pharmaceutical factories use. It compresses the granules into cylindrical pellets. Meanwhile, workers feed a copper strip into a machine called a high-speed transfer press. Its successive stations shape the copper cup that'll house the wax pellet. The first station stamps out a circle. The others progressively stretch and form the circle into a cup. The cups go into an automated assembly machine, which drops a pellet into each one. A pin then bores a hole down the center of each wax pellet. The machine inserts a rubber sleeve into the pellet hole and caps the sleeve with a brass cover. Then it crimps the cup over the cover, forming a seal that's leak resistant. Now the machine inserts the stainless steel pin that opens and closes the coolant flow valve. The pin goes right into the rubber sleeve in the center of the wax pellet. How do all these parts work together? The melting wax expands within the cup, squeezing the rubber sleeve. That forces the pin upward, opening the coolant valve. Now they heat the parts to the temperature at which engine cooling should kick in. The calibration machine squeezes the cup until the pin rises enough to open the coolant valve. The components now enter a machine which connects that valve. The valve is made up of 2 stainless steel pieces. The machine loads one on top of the other over the thin end of the cup, then pushes the valve over the end of the cup, attaching it to the wide end. On the left is before the valve installation, and here's after. Meanwhile, a press forms the top part of the thermostat, called the flange. It's made of stainless steel coated with a lubricant. As with the cup, a series of dies progressively forms the flange. Now for the final assembly. First, the thermostat's stainless steel frame. Next, a stainless steel spring. Its job is to close the valve when the engine cools. Now the assembled components go inside the spring. The flange goes on top. A tool called an orbital riveter flattens a tab on either side of the flange. This holds the frame onto the flange. The assembly machine now crimps two little tabs against the pin, keeping it from falling out of the rubber sleeve. And with that, the thermostat is finished. This demonstration shows how the melting wax pushes the pin upward, and when the engine cools, the opposite happens, so that even though you might boil over in heavy traffic, your engine doesn't have to.
So we've seen a little bit about one cooling system. The thermostat information is pretty standard, but there are different designs of cooling systems. Over the years, there have been downflow radiators, cross-flow radiators. Some cooling systems, the coolant flows in reverse, but typically, water pump pushes coolant into the engine block where it flows up through the heads, into the intake manifold, possibly out through the water outlet to the radiator, and then from the radiator back into the water pump. So it circulates like that. Typically, there's provisions for heater. So you'll have heater hoses running off, usually in the area of the water pump, that carry warm coolant or hot coolant to the heater core, so we get heat in the vehicle. Some have recovery bottles. Some have pressurized surge tanks. So we will see other kinds than what we just saw today. And the thermostats, as I mentioned in one of the videos in the shop, some of them pop open rather suddenly, and some of them open gradually as the temperature goes up, and so they begin to let a little coolant flow before it's reached operating temperature. Others go right up to operating temperature and then pop open. So we're going to see all kinds of different setups over the course of this semester. And about a little more than halfway through the semester, then we'll start talking more about air conditioning. So I hope you got something out of the video, and the way to do this, the way to handle the lab report, is write it up like you would if you were in the shop, but obviously you're not going to put down year, make, model, vehicle, or who owns it. Don't worry about that. Just describe, make sure you put your name, of course, and the date, which would be the 28th, January 28th, and just describe what you saw. Explain, and I want numbers. In other words, tell me when the thermostat opened on the vehicle. Tell me when the thermostat opened on our bench test. Explain what I told you in the video. And there's no need to email it to me. Just bring it next week. Put it under the clipboard when we start lab. I did mention in an earlier email that I'm late because something came up. And what happened is, just when I was getting ready to work on this, my daughter called and she was in labor. So as it is right now, as I'm filming this, we're still waiting for the baby to be born. So she's been in labor for quite some time now, but we had to help out with her daughter because they couldn't take her to the hospital with them. So put me behind a little bit, but I eventually got caught up, and so I hope this is at least educational. Hopefully you get something out of this and know a little bit more about cooling systems than you did when we started. I'll see you next week for real in the lab.